So today is actually the weekend, it's Sunday, but we have pushed the quiz back. So you haven't even received part of the lesson that I'm going to kind of use in this. So I'll give you a little bit of that lesson, then you'll get it again in class. Everything else will be a review. I'll go over, I'm mainly just going over practice problems though in this video. So if you need to watch the lesson, you can go back to the class recordings of whatever day the lesson fell on. So I've assigned a bunch of problems. I've already done problems on midpoints in a different video, but I'm going to do a couple in this video. And then mostly I'm not going to do any practice problems on weighted, like locating a point using weights. I have a different video where I've already done that. So these practice problems will pretty much be partitioning a line using ratios. All that means is kind of like we did before with weights, we're going to put a point on a line, but instead of using weights, or instead of giving us weights, they're giving us ratios, which we just started Friday for everybody. So if you were in class Friday, hopefully we got to that one class. I think we didn't even get to what a ratio is, so I'll explain that really quickly. Then I'll jump into doing the problems. And I told you I'm going to solve everything using weights. So I'm going to show you how to take a problem that is a ratio problem, but actually convert it into a problem where you can do the same process we did when we were given weights. I probably won't go into a lot of detail about how that happens in the video, in this video, but in class, I should cover it a little bit. All right, so with that in mind, this is what page? This is page 27 that I'm working on. So again, this is how to locate a point on a line when they give you a ratio. So just really quickly, we said that a ratio, zoom in to give myself some room, right? We said that a ratio is, it's not a fraction, but we can figure out a fraction from it. What a ratio really does is it compares sort of two quantities to each other. So I'll show you the example I did in class. I'm not going to go back to the actual, whoops, I'm not going to go back to the actual lesson, but hopefully that will work there. So I said, what if we had some marbles? These are marbles, and we had some red and some blue marbles, we said. We said a ratio compares the number of red, in this case, the number of red marbles to the number of blue marbles. So in this case, I could write a ratio that is 5 to 3. That means there are 5 red marbles for every 3 blue marbles. So that ratio has to stay constant throughout whatever the problem is. So if we had 10 red marbles, we would have to have 6 blue marbles. Basically, if the number of red marbles is doubled to 10, well, then the number of blue marbles has to be doubled as well to 6. So a ratio kind of stays constant. I didn't really talk about this because I'm doing a quicker version than I normally do, but ratios are very important in cooking. If you want to take a recipe and make more than what the recipe is supposed to make, or make less than what the recipe is supposed to make, then you need to understand how ratios work, because you need to either increase the ingredients all in the same ratio to each other or decrease the ingredients all in the same ratio together. Again, they gave us less time this year to cover that, so I didn't do the full lesson. But if you want to go back to my YouTube channel and look at last year's lesson, I went into a lot more detail about ratios. You would just go to my YouTube channel and search all the videos and look for, it probably says partitioning is in the title. I might, if this doesn't run too long, I might go look it up for you, or maybe I'll look it up in class and show you the video, and then it'll be recorded in the class lesson. So again, that's what a ratio is. It compares to. So if we wanted to talk about total marbles, we would say 5/8 of the marbles are red. And to get the total marbles, we just add the two ratios together. So we just add 5 plus 3, and that tells us the total. And then again, 5 is the number of red out of the total of 8. 3 would be the number of blue out of the total of 8. But this is very important with line segments. You've got to understand that the total number of line segments comes from adding the two values in the ratio together. And you'll see what I'm talking about in a minute. So again, to get the total number of segments or the total number of values, depending on what you're talking about, you add the two numbers in the ratio together. So with that in mind, go up. I'm going to just jump straight into the problems. Actually, I'm going to zoom in one more time. So I have not really done the examples. This is the super fast version this year. But if you want to go back and look at the examples, maybe if I have time, I'll try to do some examples for the retakes. It won't happen before the first quiz, though. So here we have a line segment. It goes from M, which the value of M is 2, to J. That's the line segment we're talking about, and the value of J is 18. So what we want to do is it's asking us in problem number 1 to basically put a point or locate a point X on the line so that we split that line into a ratio of 3 to 1. Now, I'm going to tell you to just ignore all of this. If you really understand ratios, then you can probably use those, but I'm giving you a process here where you don't really need those values down there. Again, it may help you, it may confuse you. So I'm giving you a process as if there were no values, no dashes, like they hadn't separated the line. Here, I'll just do this. It's as if you have this line. 2 all the way to 18, nothing underneath. So it's more like this right here. Then that would still be M and what is J. I was trying to remember the other letter. J. So I'm giving you something more like that instead of what you see on the left. Yeah, I'm gonna get rid of it. All right. So here's the key again. We talked about what division is in class. If you were in class, you remember the little, some classes actually did more of an activity, some we just kind of did it together. But we said if you want to divide a total amount of anything into equal groups, that's just division. So if I want to take 12 marbles, we'll stick with, and I want to create 3 equal groups, I'm just dividing by 3. That's what division is. It's grouping. So if I do that and I get 4, so that is the number of groups, and then the 4 would be how many in each group. This was the activity, quick version of it. So we said that's really all division is. We're just taking a total and we're splitting it up into equal groups. And then it'll be the same number in each group. That's the key, same number in each group. Then we said, well, line segments are a little different because we don't really have a specific number in a group. Like it's not a group of things, it's just a line segment. But we do kind of the same thing, but we're just measuring it in a different unit and in a different way. Instead of having a number of items, we're measuring the length. So if we wanted to take the length of a line segment, like one long line segment, and split it into equal length smaller segments, we're still just doing division. So if I asked you to take, I'll just do a simple version. If I asked you to take this line segment, again, ignore this. I'm just trying to give you a quick example of the lesson, super fast version of the lesson. If I want to take that line segment and split it into 2 equal line segments, first of all, I have to figure out what the total. So we struggled a little bit on this in class to find the total length of a segment. And we did this very, very early in class, but we said length is just subtraction. So the first thing you have to do is find the length of the big segment, the original segment. So length is subtraction. So if I want to find the length of that is not 13, it is not 16. We have to subtract. It's like a game board. How many spaces do you travel if you start on space 3 to go to 13? Well, you could count 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That would be 10 spaces you would move. Length is the same thing, except we're going to use subtraction. We would say 13 subtract 3 means the length of that segment is 10. So now that I know the total length of the segment, if I want to create two equal smaller segments, then I'm dividing. So division is how we create whatever number of smaller segments we want. So if I know 10 is the total length and I want to create two segments that are equal length out of the 10, I get 5. The 5 is how long each individual smaller segment is. So the length of each small segment. Again, 10 was the total length of the big. I wanted to divide that into two equal length smaller segments. So that is how many smaller segments. So how many small segments. And then the 5 is how long each small segment would be. So again, the 2 and the 5 are the key. The 2 is how many smaller segments. The 5 is the length of the smaller segments. That's the only thing you really need to get down when you're doing a line segment and partitioning it like this, like a flat line segment. It's a little bit trickier when you do it on a coordinate plane, and I'm going to show you a whole different way to do it, but I'm just trying to decide how much I'm going to do in this video. All right, so anyway, let's go back to the problem and let's finish that first. All right, so in this particular case then, I'm going to just say we go from 2, I'm going to draw out a new line segment, 18. The letters aren't really that important, but I'll put them in there. All right, so 2 to 18. So it tells me I want to partition it in a ratio of 3 to 1. So first of all, I need to find the length of MJ. I guess we could do that. So that's 18, subtract 2. So the length of that is 16. The long line segment is 16. Now, if I want to partition it in a ratio of 3 to 1, that means I want 4 total line segments. So that's the next piece you have to know. So step 1, that's find the total length of the big segment. Step 1, total length of big segment. There we go. Total length of the big segment. That's step 1. Step 2 is how many small segments do I want? And you get that by adding the two numbers in the ratio together. I'm going to abbreviate, but that means how many smaller segments? How many small segments do I want to make from the one big segment? So I want to make 3 and 1, or the ratio is 3 to 1. So that means I want to make 4. So that would be 4. And now I need to figure out how long will each one of those small segments be. They all have to be the same. So that's where I take the 16 total divided by 4. And I will, again, normally write 16 divided by 4 like that. But just for the purpose of this one, I'm doing it this way. So that means each segment will have a length of 4. So it just happens to be that they're the same in this problem. That won't normally happen. Again, that is how many smaller segments. And that is the length of each smaller segment. Length of each. All right. Hopefully you got that down. You can always rewind if you need to. I'm going to erase a bunch of this to make room. So that division part would be step 3. I forgot to write that. So step 3 would be dividing to determine how long each smaller segment was. So write that down in your notes. Step 3, divide the total segment by the number of smaller segments you want, and that tells you how long each smaller segment is. So if each smaller segment is 4 is what we came up with, I would say, well, if I want to create those 4 segments on this line, which I do, I just need to keep adding 4. So I would add 4 to the 2, and that would get me a point right about there. So 4 plus 2 is 6. Then I would add 4 again. Well, that would get me probably about there. And I'm just doing this by freehand, so it's probably not perfect. Plus, well, definitely not perfect. Plus, so 10 plus 4 is 14. And if you do this correctly, you better land exactly on that number when you add the last line segment in. So 14 plus 4 is 18. So I know I did it correctly. So I now have 4 equal length line segments. One, well, I should probably not do it that 6 on this one. Oh, that didn't work. There we go. So 1 there, 2 there, 3 there. That's hopefully you can see that blue, and then 4 there. So I have 4 equal length line segments. They're each 4 units long. Now to put the point on the line, I just have to go back to the ratio. Once you've created the 4 segments, I say, okay, well, 3 to 1, that ratio just means I want to have 3 of the line segments on the left and 1 of the line segments on the right when I put my point on the graph or on the number line or on the line segment. So I just need to say, okay, well, here the yellow is 1, the green is 2, the blue is 3, and that's then where my line would go. So I'll do it, I guess I can do it in black, that's fine. So my point would go right there. If I were going to actually draw it on the line, I would put X right there. More likely, they're going to ask you, though, what is the value, which would be 14. So again, just to make sure, I have 1, 2, 3 segments on the left, 1 segment on the right. That matches up with my ratio. All of them are the same length. I landed exactly on 18, so I know I'm in good shape. Now you can get decimals in these, but nothing changes. So sometimes you will get decimals, or you may have to use fractions sometimes. So just know you're going to have decimals and fractions involved. I gave you this is an easier one than you might get normally. I'm going to just show you this. I'm not going to explain it in this video. I'll explain it in class on Monday. There's another way to do these problems when you get a ratio. Ratios are the opposite of weights. And I'm going to explain that in class. I'm not going to go into it in this video. Or you can watch last year's video on ratios. And I'm pretty sure I explained it in last year's video on ratios, not the one in weights. So I could actually do this problem using weights. And I told you I would show you how to, and I will tell you right now, when you do a line on a coordinate plane, you're going to want to know how to do it this way. It's not always easy to do what we just did on a coordinate plane because you have an X and a Y value. You can't just split that line up because the line goes diagonal. You can't just split it up necessarily by dividing one number by one number. So if they are opposites, again, my 3 is my first number, my 1 is my second number in my ratio. I'll go ahead and write 2 there and 18 there. The only thing you have to change, and again, you have to remember, weights and ratios are opposites when it comes to doing this putting a point on a line thing. Are opposite of ratios. They're opposites. So if they are opposite, I mean exactly opposite. I can do this same problem using weights. I just need to change the ratio into the opposite ratio. So instead of 3 to 1, I want to use weights of 1 to 3. So I could write a weight of 1 here, a weight of 3 here. You erase or review, go back and look at what I did. You can. Now, if I go ahead and I solve it out using our, oop, that didn't work. I meant to do that. Now, if you solve it out using our weights method, man, we say what that circling means multiply, remember? So that would be 1 times 2 is 2. 3 times 18 is 54. I divide by the weights added together, so that would be 1 plus 3. So I would get 56 divided by 4. And if you do the math on that, you get the same answer, 14. That is going to be much easier to do when you get a problem that has a coordinate plane involved, like a graph. Doing a horizontal line with only one endpoint number on both sides isn't too bad to try to figure out using the divide the length of the line into equal length segments and then create all the smaller line segments like I did the first way I did this one. But on a coordinate plane, that does not work out as easily because you have X and Y values and you can't really do that division thing as easily. Sometimes you can. All right, so I'm just going to kind of go through now and do the problem. I'm going to use the weighted average way to do all of them. If you want to divide it up yourself and figure out where it goes, you can do it that way. I don't care. Just know that that's going to be tougher on the coordinate plane. So again, it's the same line they give us. They don't change the line. They only change the ratio. That's a 2. That is a 18. So there's my ratio. They don't give me any. So here's how you're going to know when to do it using the normal weights that they give you versus having to flip the ratio around. This problem doesn't say anything about weights. It just has a ratio. It has a ratio that has that little colon thing in it. If it doesn't say anything about weights, and if it gives you something like that, a ratio, that's when you need to reverse them if you're going to do it the way that we did the weights problem. If it gives you weights in the problem, then you're just going to use those as the weights. All right, so that's just something you got to memorize. You just got to know if they give you weights, do it the same way we did weights. If they don't give you weights and they give you this kind of ratio thing here, then you have to flip them. Ratios are the opposite of weights. So when we're going to do it the weights way, I have to flip it, and the weight of the first value would be 3. So the weight is 3. I'm flipping the ratio around and putting a 3 there and a 2 here. There is sometimes when it gets a little tricky and they'll actually say split it from a ratio from J to M. So they'd actually be going in reverse and you got to figure it out. I'm not going to cover those exceptions. Just know that they can make it trickier. Just if it's a normal problem, though, you just flip the weights. So again, I put in this 2, I put on the right side, this 3, I put on the left side. I flipped them when I did the weights up there. The weight doesn't show up very well. Let's do this. There we go. So that's the only thing you have to remember to use the weights, the weighted average method that we use. So now I just go in, I circle them, circle them. Ah, why is my thing not working? Oh, don't tell me. No. That was really weird. Don't know what happened there. Hopefully it's still recording. Yeah, I don't know what just happened. So I do that. Circling means I'm going to multiply. 3 times 2 is 6. I'm going to add that to 2 times 18, which is 36. I divide by the weights added together, which is 5. So that's, again, 5 comes from the 3 plus 2 up here where the weights are. 3 there, 2 there. So that's how I got the 5. And if you do that, you get what? 36 plus 6 is 42 divided by 5. So divide that by 5 would give me what? 8.4. Now be careful because sometimes kids then try to do something with that. If you do this the weighted average way and you don't do it the ratios way, you don't have to add, like that's your answer right there, just like it was when we did weights. The point should go at 8.4. You're done. Just remember that's the answer because I'm going to erase everything. If you need to go back, you can. So the answer would be somewhere right there at 8.4. And I could kind of look at it and say, well, does that make sense? Because the left part, if the ratio is 2 to 3, the left part should be a little bit shorter than the right part. That's kind of what a ratio means. Like when we did this one before, the left part was 3 times longer than the right part because we needed three smaller line segments on the left, 1 smaller line segment on the right. If I look at these two lines, I can kind of say, well, is that green line a little bit smaller than the blue line? Yeah, that's a little bit smaller than the blue line, so that would make sense. It shouldn't be way, way smaller because a ratio of 2 to 3 means they're relatively close in size to each other, unlike 3 to 1, where one should be quite a bit bigger than the other one. But yeah, 8.4 makes sense. Really quickly, if you wanted to do that one, the ratios way, I guess I'll show it to you super fast just so you know if you got it right. So we'd start at 2, go to 18. The total length is still 16. God, my pen is not working very well. So the total length is 16. I need to divide that up into equal length segments, and I get the number of segments by adding those two together. So I want 5 smaller segments. Man, it's driving me crazy. Smaller segments. So if I divide by 5 each, so this tells me how long each smaller segment would be. You divide that out, it comes out to be, and I would encourage you to learn how to work with fractions because sometimes you'll have to. But in this case, it works out okay to use decimals. So each smaller section is going to be 3.2. So I could just keep adding 3.2 over and over and over again. So 2 plus 3.2. I'm trying to make this as accurate as possible. So 2 plus 3.2 would be 5. Tell you what, let me do this. Let me make the skinnier. 5.2. I didn't really make it skinnier there. Try that again. If I added 3.2 again, that would be 8.4. If I add 3.2 again, that's 11.6. If I add 3.2 again, that would be, what would that be? 14.8. And then if I add 3.2 again, that's an 8. And then if I add 3.2 again, I would fall right on 18. So again, there's My first time I added 3.2. My next time I added 3.2. My next time I added 3.2. My next time I added 3.2. Why is this not working? And then my last time I added 3.2, I fell right on 18. So again, I would have to use an extra highlighter there. 1 segment, 2 segments, 3 segments. Whoops, what just happened there? I don't know. 3 segments there, 4 segments there. And here, we'll just use a regular pen color and I'll just stay above it. And then 5 segments there. So I created 5 equal length segments, which is exactly what I wanted from the ratio. And then I should have 2 on the left and 3 on the right. So that means my point would have to be right there, which is the 8.4 that we got earlier when we did it using the weights. And we reversed the ratio and did it as a weighted average problem. All right, so I'm going to go ahead and move a lot faster now, just so you have answers. Actually, I probably won't even do all of these. I'm going to do them the weighted average way. If you want to try to do it the ratio way, if you kind of understand that dividing into equal segments, that's fine. If you want to divide it into equal segments, that would be 4 total segments. That would be 5 total segments you would need. That would just be a midpoint. That's the equivalent of the weights being equal, right? Because if I flip that to do it the weighted average way, I'd still have 1 and 1. And we said before, if the end points are equally weighted, you're really just calculating out the midpoint. So you do need to understand that problem right there is just calculating a midpoint. Neither endpoint is more important than the other. So you're going to wind up finding the point right in the middle. This would be, so it'd be a total of 2. So if you're going to do it the ratio way and you're going to divide and figure out how many smaller segments you need, those are the answers right there. You'd need 4 in problem 3, 5 smaller segments in 4, 2 smaller segments in problem 5, 8 smaller segments in problem 6, and then you got to do the division thing, figure out how long each one would be, and then add that over and over and over until you get all the segments. And then figure out how many segments on the left, how many segments on the right. A lot more work, I think, than just doing it the weighted average way. Because if I'm going to do it the weighted average way, and I'm going to redraw the line, I'm not going to do 3. 3 is, I think, easier. I'm going to start with 4. So it says I'm going to go from B to F, basically. So find it so that I'm putting X in between B and F. I know that because there's B there, there's F there. That's how I know I'm going from here to here. So I'm just going to redraw that line. Remember, you just ignore all the other points. I hate that they don't give you separate number lines for each of these, but they don't. So I would be going from B, which is -5, to F, which is what? +5. Let me see if I can do this easily. Yeah, that's not too bad. We can work with that. Oh, shoot. No, we can't. We just needed to be able to see what the weights are. So my weights, now here's the tricky part. Remember, if they don't give you weights and they give you a ratio, but you want to do it using that weighted average way, you have to flip the ratio. I did not mean that. So I have to flip this ratio if I'm going to do it the weighted average way. The weights, so instead of the left weight being 3, the left weight is going to be 2. I'm flipping the ratio to do it the weighted average method. I'm assuming that I'm going from left to right. Sometimes they will give you information and they want you to partition the line going from right to left. Again, if they give you that, that's just a tricky question. We are not going to be able to cover everything. You just kind of have to adjust to the direction they tell you. But normally they're going to go left to right. So I'm just doing it the left to right way. So that would now be 3. Again, you have to flip the ratio if you're going to do it using weights. They're opposites. Weights and ratios are opposite. So I need to flip it. Now I just do it the way I do a normal ratio, and then I'm done. I don't have to do anything else different. So circle. Oh, what was I forgot the value. 5. Circle. Doing the math, that is -10 plus, what's that, 15. I would then divide by the weights added together, 2 plus 3. So that would be +5 divided by 5. 1 would be my answer. So I would put a point. Now I'll kind of come back. So 1 would be my point. I would put right there. If I wanted to kind of just say, well, does that make sense? Is the left side looking at the ratio? That ratio tells me the left smaller segment should be a little bigger than the right smaller segment, because I have a 3 on the left, which is a little bigger than the 2 on the right. Ratios of line segments has to do with the length of the line segments. I don't know if I said that in this video. I will in class. That's kind of what these numbers are telling you. So if the left number is a little bigger, then the left line segment should be a little bigger. If the left number is a lot bigger, I'm sorry, if the right number in that case that I just circled is a lot bigger, then the right segment should be a lot bigger after, once I put my point on the line. You'll see that. If they're the same, then once you put your point on the line segments you create should be the exact same. That's why it's the midpoint. So is that green line coming back over here now? Is that green line just a little bigger than yellow? Yeah, that is just a little bit bigger than yellow, so that makes sense. So I feel pretty comfortable with my answer. I'll do one more. You'll have time to practice in class. Let's do the bottom one, 5 and 3. So I'm not, I guess I can, no, I can't. Oh, I tell you what, here, let's do this. I can do it if I do this. There. Now I can kind of show you. Whoop, or not. So you have this in your books if it's too small on here. So I'm doing number 6. Again, if they give me ratios and I want to do it using weights, I have to flip the weights. So instead of the ratio 5 to 3, using that as the weights, I have to flip it. And my left weight is going to be 3. My right weight is going to be 5. I'm going, what letters am I going from? It looks like I'm going from F to D, because I'm putting Z in between F and D. You won't have to worry about that on my quiz, hopefully not even on the district or state stuff. I don't like the fact that the book makes you figure that out, but again, I just know that that's the case because of the way that's worded. You're putting Z between F and D. So I'm going to go from F to D, which is a pretty short line segment. So that's the line segment I'm using. So I'm going to redraw that. So D is 1, F is 5. I'm going from that to that. I'm not going to write the letters because I'm going to write the weights up above. Let's see if I can do this. Yeah, that's enough room there. So again, I have to flip the ratio. I do not put the 5 as the weight on the left. I put the 3. They are opposites. Ratios and weights are opposites. I'll explain why in class. Hopefully we'll have time. So that's how I write the weights. Now it's just a weighted average problem. I circle that. I circle that. That means multiply. 3 plus 25. 5 times 5 is 25. divided by 3 plus 5. I add the weights together. So that gives me what? 28 divided by 8. I'll just write here. You convert that into a fraction. I'm sorry, a decimal. That is already a fraction. You convert it into a fraction, you would have 3.5. I'm not going to go into how that's 3.5. You have calculators. So if I, again, now if I go up to the line, and it's a little trickier to see because this line is so small, but if I go up to the line and I imagine my point being right in between 3 and 4, oh, wait a minute. Oh, I might be able to fix that there. Like, yeah, there we go. There you go. That's pretty good, right in between 3 and 4. Yeah, I can't really get any closer than that. Now, if I imagine, okay, how long? There's the left segment, or that's right, the right segment. Here's the left segment. I went from D to F. And the left segment should be a little bit bigger than the right because it's a 5 versus a 3 on the right. And that looks like that could probably be the correct. So I feel pretty comfortable with that. All right, so that's all I'm assigning is 1 through 6 from partitioning. I might have some other problem. Oh, I'm sorry, we got to do it on a graph though. What am I thinking? We will do this in class, and again, they're making it a lot tougher on here than I will on their quiz. They're trying to put a whole bunch of graphs. So I'm going to still do it really quickly. Oh, actually, you know what? I wonder if there is a example problem maybe we could do. Ah, no, not there. Let's see if maybe up above that. That is one. Oh, here we go. All right, here we go. So it says located a point. There, yeah, we'll use this one. Now, I don't always give you, and I think I've told you in this class, I don't always give you the X and Y. So hopefully you can find the X and Y. But let's go ahead and we'll do this one. They've already kind of done it for you, but I'm going to use this one to do as your example. I'll have to give you some more examples in class to do that are on a coordinate plane because that's certainly the most difficult thing. And I just lost where we were. What's just happened? Oh, there we go. Yeah, I was trying to. Huh. I don't know why I can't erase that. Not sure what's going on there. There. All right, so this is as much as I can zoom in. It's in your book though. You would have to ignore all of this. You would not get any of that. Oh, there is a formula in the book for partitioning. I do not teach that because it's rather complex in my opinion. I kind of went over it. I mean, it's sort of the same thing we did in class, but when it comes to a coordinate plane, that's going to be extremely challenging, I think, for most people. I would use the weighted average method anytime it's on a coordinate plane. If they don't give you weights and they give you a ratio like that, all you have to remember to do is just flip that. Weights and ratios are the opposite. So instead of A being 1, because 1, so here's the ratio. This is the ratio they give you right there. So instead of A being a weight of 1, we just flip it. It's 2. Instead of B being the 2, it's the 1. And once you flip it, I think you guys are relatively comfortable with doing this. So now we just come in, we multiply that times the X value, and we multiply, oh, I should have written that in a different spot. Actually, I can just hold on. I can just move it. And we multiply 1 times the X value over there. So if I do that, let's see, 2 times -5 is -10. I'm going to add that to 1 times 6. You have it in your book if you can't read it as well, because I covered it up a little bit. Divide that by the weights added together. So I get -4 divided by 3. So that is my x value. I use the x values to find that first answer. So that is the x value of my final answer. My final answer is all, God, why is the pin not, or it's not a pin, but so again, negative, I'm going to leave it as a fraction. If you used a calculator and converted it, you get -1.33333 forever. So now I need to do the same thing with the y values. So I circled the weight again, but now with the y values. Circle the weight with the y value. I do the math. I do the multiplication. 2 times -2 is -4. So that's what I just did right here. Then 1 times 2 is just 2. I divide by the weights added together, which is, I'm just going to go ahead and add them together, 3. So that gives me -2/3. So my y value should be -2/3. Hopefully you can see that, 3. So that should be my point. And we said the nice thing, if you need to go back and rewind to see some of that, you can. If I did it correctly, I should land on the line when I go to put that point on the graph. Like that's what I'm doing. I'm locating a point on the line. So if it doesn't fall on the line, I did something wrong and I'll have to redo it. So I can't zoom in anymore. So this is going to have to be certainly an estimate. -4/3 would be somewhere right in, oop, it's not writing, let's try it again. -4/3 would be somewhere right in the, why did that not? Somewhere right in there on the x-axis, somewhere where that green line is. Then I would go down and I would say, well, -2/3 would be somewhere right there. So sure enough, if I connect those two, it looks like I'm hitting the line. Hard to tell when I'm using fractions and having to zoom in and out, but that looks pretty good. Actually, they might even give us the answer, and yeah, they did actually. Didn't notice that. So a lot of times they give you the answer for the first example problem. So that's why they can be pretty helpful. Normally they give you then a check problem after it. That one does not though. So there are some you can do in here, like yeah, here's one you can do with the line to the right to practice that. I'll tell you what, I'll do that for you. I'll assign that problem number 17. I gotta remember that one. So problem number 17. Oh, there are also IXLs, I'm pretty sure, on partitioning. I know I already assigned the IXLs on midpoints. I mean, I put the thing up in class for you to see it, but they're on that same sheet that's up in class that you can take a picture of. And I'll probably mention them in class. So if I want to do this the weighted average way, I am not given weights. I'm given a ratio, so I'm going to need to flip that. That means the weight of M will be 3. Weight of N will be the 1. But once I, oh, and they don't give you they don't, here, let's change that. They don't give you the X and Y, so you got to be able to figure out the X and the Y. So this is negative, and hopefully you can do that on your own because that's something that you are expected to know in geometry. Why is that not small line? I don't know what's going on. Stuff here. -6, comma, -4. M And N is +6, +4. And then, like I said, now, if you're doing it the ratio way and you're going to try to split that line up, it's very difficult to split a diagonal line up. That's why I say just doing it the weighted ratios way is better. Just flip the ratio. So that would be 3, and that would be 1, because I'm flipping this ratio around. The number on the right becomes the weight on the left, vice versa. So now I just go ahead and I solve it out. So that times, oh God, this pen is trying to this stylus or whatever it's called. Multiply that times that, multiply that times that. So I would get -18 plus, what is it? 6 divided by 3 plus 1. I add the weights together. So that will be -12 divided by 4. So the first part of my answer, is -3. So my x value is -3. Now I do the same thing again. Circle the weight, and the y. So now that tells me to multiply. So 3 times -4 is -12. I'm going to add that to 1 times 4. And I'm just going to go ahead and add the weights together and give me 4. So that would be -8 divided by 4. So that would be -2. And I can sort of check my answer by knowing that the left part of the line, so if I look at the ratio, it's telling me the left part of the line should be a lot shorter, the smaller left segment, because I only have a 1 in front and a 3 in the back. So the front part of the line, after I put the point on the line, should be a lot shorter than the back part of the line, the right part of the line. So I'm going to put my point at -3, -2. I'm going to get rid of all that. You can always come back if you need to. So -3, -2. And the good news is I fall right on the line. So that makes me feel pretty good about my answer already. That's the left part of the line. So that would kind of be represented by the 1. That's the right part of the line. So that would be kind of represented by the 3. And that makes sense. That green line does look like it's about 3 times as long as the left line. And that's what a ratio is telling me. How long should the left segment be relative to the right segment? So that makes sense. But again, I did it using weighted averages. So that's all I'm going to do for this video. I'll see, and I don't know that I'll do any more Monday night right before your quiz, but I'll probably wind up doing more problems at some point. I did midpoint problems, I think, in the other video, the other practice problems video where I did weights. So if you need some midpoint problems worked out, I don't even know if I've assigned them in class yet. I'll certainly do that Monday, but mostly for the midpoints, I think the IXLs are pretty good. And actually, probably for partition, the IXLs are not too bad either. They're difficult, but if you can do those, you should be in pretty good shape.